The last type of algebraic domain we're going to talk about today is going to be mixing the previous types, polynomials, basic rational functions, and basic radicals. So we're looking at a combination. Basically, we're going to apply all of the situations that we have earlier. So on this first one, and I apologize for any background noise, this first one, I look and I see a radical. So we're going to have to apply that. And I also see a denominator. So to keep it simple, my first part, I'm going to say, well, 2x plus 1 can't be 0, so x can't be negative 1/2. That's a restriction that 0, we can't have 0 in the denominator. Okay, you can't divide something into 0 parts. The other part, remember square roots, this is an even root, so the part underneath is restricted to positive or 0. So the x plus 2 greater than or equal to 0, so x is greater than or equal to negative 2. So both of these have to apply. So we have basically this and this. So if I put this on a number line, it may be helpful. If I look at greater than or equal to negative 2, we're talking about all of this area. Okay? And x can't be negative 1/2. Oops, let's get negative 2 on there. And x can't be negative 1/2. Well, negative 1/2, if 0's over here, then negative 1/2 is somewhere in here. And that tells me we basically have this open circle. So, with that in mind, our domain consists of everything from negative 2 up to negative 1/2. And then from negative 1/2 to infinity. So we have these two intervals. So my domain is from negative 2 to negative 1/2, whoops, parentheses, union negative 1/2 to infinity. My third situation, or second situation, g of x, consists of three parts. We have a polynomial, which is all real numbers, no restrictions. We have a denominator, so we have x can't be 2. We have a radical, so x plus 1 is greater than or equal to 0, so x greater than or equal to negative 1. So I've got x greater than or equal to negative 1. So if I'm looking at the same kind of thing on a number line, it looks like this. But I can't be 2, so I have a hole at 2. So it looks something in this regard. So my domain is from negative 1 to 2, skip 2, and then from 2 to infinity. If you look at the graph of that, I think you're going to find that it kind of just starts at the point negative 1, has an asymptote at 2, and then goes on infinitely from there. You might want to check that out. And that is it for mixed domain.